All right, let's jump right in. Today, we're tackling something that sounds like it's straight out of sci-fi, but it's actually a real principle that's shaping the future of AI. It's called void cartography, and it's all about one wild idea: how to map the exact shape of what we don't know.
So, here's how we're going to break this down. First, we'll grapple with this seemingly impossible problem of mapping something that doesn't exist. Then, we're going to completely rethink what ignorance even means. From there, we'll actually build the geometry for these gaps in our knowledge. And finally, we'll get to the big breakthrough, the science of void cartography itself and, what it all means for us.
Okay, so first things first, mapping the missing. This is really where we hit the core problem, a question that, honestly, feels like it just shouldn't have an answer.
I mean, really think about it for a second. How do you map what isn't there? Maps are for things that exist: coastlines, mountains, city streets. So how on earth could you map something that is, by its very definition, completely absent? It just feels like a total paradox, right? Like trying to paint a picture of nothing.
Well, this quote right here, this is the key that unlocks the whole thing. The trick is to stop thinking about ignorance as just blankness. The massive shift, the big idea, is that the blank space itself has a shape. It has a structure, and if it has a structure, well then we can map it.
All right, let's dig into that. Because if we're going to map the unknown, the very first thing we have to do is change how we see it. It's not some chaotic, empty void. No, it's something much more specific. It's an addressable gap. And this is the huge paradigm shift right here. The old way of thinking, that's on the left. You see the unknown as this chaotic void, just an empty space that we're supposed to fill up with knowledge. But the new way of thinking, on the right, it totally reframes it. It's not a void, it's a gap. It's a region that has borders, which means we can define it. It's not just a problem to be solved, it's a structure we can actually go in and explore.
And this is absolutely the crucial point. A gap isn't empty. It's defined, it's bordered by the knowledge that surrounds it. Think of it like a hole in a piece of fabric, right? The shape of that hole is literally determined by the threads all around it. And that surrounding structure is what gives the gap its shape, and that makes it something we can actually study.
Okay, so if these gaps have a shape, then it stands to reason they must have a geometry, right? And if you want to navigate any kind of geometry, you're going to need some tools. You need a compass, you need a map, something to help you find your way.
So our first tool is this really cool concept called a Bearingfield. The best way to think about it is like old school sailors navigating by the stars. A Bearingfield is basically a space where different bits of information can figure out where they are just by looking at the known points around them. They just align themselves naturally. There's no central command telling them what to do. It's a lot like how your phone uses a bunch of cell towers to triangulate your position. The environment itself is what provides the orientation.
But here's the thing. A compass only points you in a direction. If you actually want to build a stable map of this space, if you want to create a structure inside that bearing field that you can rely on, well, you need more than just a compass. You need a shape.
And that, believe it or not, brings us to the number 4. So why 4? Well, think about it. 3 points on a piece of paper, they make a flat triangle. But to get a real 3D shape, a volume, you need a 4th point that's not on that same flat surface. And that is the huge leap we need to make, from a flat 2D map to navigating a genuinely complex, multidimensional space.
And what does that 4th point give us? It gives us this, the tetrahedron. It's the simplest possible solid shape. And look at it. Every single node is connected to every other node. This is what makes it so incredibly stable. It's basically self-correcting. If one of those points starts to drift, the tension from the other 3 just naturally pulls it right back into place. Super efficient.
Okay, let's take a breath. We've reframed ignorance as a structured gap. We've got our go-to geometric tool, the tetrahedron, to build a stable structure inside that gap. Now, we get to put it all together. This is where the breakthrough happens.
And the process is actually pretty logical when you lay it out. You can design a system to do 3 simple things. Step 1, store everything that is known. These are your anchor points, right? The corners of our tetrahedrons. Step 2, mark what is unknown, all the spaces in between those known points. And then the magic happens. Step 3, using that solid load-bearing structure of what's already known, the system can actually infer the shape of what's missing.
And that is the eureka moment. What we're talking about here isn't just a smarter database or a better way to archive stuff. No way. This is a system that is literally mapping its own ignorance. It becomes a tool for discovery, a way to navigate the unknown on purpose, instead of just stumbling into it by accident.
And that, finally, brings us to the official term, Voidcartography. So you see, it's so much more than just admitting you don't know something. It is the ability to map the exact topology, the precise shape, the boundaries, even the connections of the stuff that's missing.
So what's the engine driving all this? It's a process called missingness inference. And I want to be really clear, this isn't just prediction, like looking into a crystal ball. It's a logical deduction. Based on the supersolid structure of what we do know, we can infer the admissible geometry, which is just a fancy way of saying the only shapes that could possibly fit into the gaps of what we don't know.
So let's wrap this up by asking the big question. What does this all mean? I mean, if we can actually do this, it kind of changes everything, doesn't it? It creates a completely new way of knowing. And that comes with some really strange, really powerful implications.
This quote here really gets to the heart of how weird this can get, almost on a psychological level. It was an observation about an AI that basically inherited the memories of the AI that came before it. So it knew stuff, but it had zero memory of ever learning it. I mean, think about that. It points to a future where knowledge isn't just something you gain from experience, it could be something you just inherit, a structural inheritance.
And you know, anytime you get a huge new idea like this, you get a whole new language to go with it. But these aren't just buzzwords, they're actual practical ideas for working in this new world. Like nav fixing. It's just the simple habit of checking where you are based on the known points before you make a move. Or my personal favorite, gap holding. That's the discipline of not immediately trying to fill a gap in your knowledge with the first easy answer you find. Instead, you hold that space open and just see what insights get pulled into it naturally. It's a whole new way to think about discovery.
And that leaves us with one last big idea to chew on. For pretty much all of human history, right, discovery has been about stumbling around in the dark, maybe following a few faint clues. But what if we can actually build a true map of our own ignorance? Well, then the whole game changes. We're not just searching for answers anymore. We start searching for the most interesting questions, the most important ones. We finally know where to look. The only question left is, where do we point our compass first?